Dear students, in the previous videos, we discussed about DFA, NFA, epsilon NFA, and the representation of such finite automata using regular language. And we do have regular expression for such languages. Hereafter, we will have another set of language called context-free language. We call it as CFL. And remember, if there is a language, there should be grammar. So we call it as context-free grammar, which is grammar to implement this particular context-free language. Let us see what is the context-free language and how it differs from regular language. I have given one regular language and one not regular language. What is that particular regular language? Ending with 1-1, ending with 1-1, ending with 1-1. Starting can be anything. So the language ends with 1-1. Consider not regular language. AB, AABB, AAA, which means how many number of A's, that many number of B's. It is another set of language. Now, implementation point of view, it doesn't need a memory. It needs only a limited memory, very limited memory. That is, a state will work for the given alphabet. That much is enough. But here, we need lot of memory because we have to count. We need a counter. Because how many A's? Sir, 3A, 3B. This counting is the trouble. Because of the counting, we need memory. Because of the memory, it is not regular language. But there is no need of memory, so it is called regular language. Okay. And what is its expression? The expression is ends with 1-1, starting can be anything, 0 or 1, any number of times. What is its expression? The expression is A power n, B power n. That means how many number of A's, n number of B's. We call this language as a regular language because finite automata accept this language. Will it finite automata accept this language? No. Reason, it has a memory. Finite automata doesn't have a memory. So finite automata does not accept these languages. So what is context-free language? It is a class of language which includes both regular as well as not regular. Hereafter, all put together we are bringing under one single umbrella called context-free language. So definitely to implement a context-free language, we need a memory because we are going to implement not regular language as well as we can include regular language also. So context-free grammar helps to construct context-free language. Okay. Sir, finite automata is a machine to accept this language. Am I right, sir? Yes. Which machine will accept this language as well as this language? It is Pushdown Automata. Remember, finite automata won't accept CFL because of memory issues. Pushdown Automata accept this context-free language. I will just give a simple example how to discuss about context-free language. Okay, that is, let us consider not regular language and we are going to discuss its grammar also. That is A power n, B power n. How many number of A's, that many number of B's. So we are going to create above language by some substitution technique. I have taken one example from the language. Let us take one string. What is that string? How many A's, that many B's. Now if I ask you to analyze this particular language, analyzing is very important. Sir, start from here, sir. A, total 4 A, sir. B, 4 B, sir. So how many A, that many B. Like that also I can do. Or I can do in reverse also. B, A. That is how many B's, that many A's. Now one more technique I am going to do. Go to the center part. Okay, assume the red color line what I am showing is the center part. For this side A, this side B. Again, one more A, one more B. Again, one more A, one more B. Again, one more A, one more B. That indicates how many A, that many B's. So, I will start from AB. one more time AB, one more time AB, one more time AB. I can expand how many times I need. If you consider this as the logic, starting from here AB, AB, another, the center point is important. So hereafter the center point I am going to call it as S. Who is S? Start state. We'll discuss more. So let us consider the center point as ASB. Now who is this S? Again ASB. Again we will discuss more. Now the basic logic here is I am standing in the center point, that is the initiator starting point. This side A, this side B, this side A, this side B. Sir, but in this particular given there is nothing called S, no problem. This S we can delete by another concept called epsilon. What is that? Epsilon indicates if you replace S by epsilon, epsilon is nothing but null. Nothing is there. Okay, already we know it is empty. Now, two concepts I created here, both side A and B, that is one side A, one side B, and we are going to kill that particular S by epsilon. Now, hereafter it is not a concept. It is rule 1. This is rule 2. Okay. Based on this rule, let us how to create this. Okay. What is there? Sir, using rule 1, start your rules. That is the technique. Yes, you replace by ASB. I don't want this. I need this whole term. Many A's and many B's. Okay, sir. Replace again S by the same rule 1. Done. Yes, I replaced by ASB. Sir, already one A, one B was there, Yeah, he will be there in the boundary. Now what happened? 2 A's, 2 B's came. Sir, I need 4 A's, 4 B. I hope you got it. Continue the same work. Replace this S by this S by ASB. Already 2 more A's, 2 more B's. Come on. Sir, I reached 3 A's, 3 B. What is our target? 4 A's, 4 B. Sir, one more time you do, sir. Problem solved. Come on. Replace S by ASB. Yes. So 4 A's, 4 B. I achieved my result. Sir, I don't like this. Yes, sir. How to remove? Okay. You just remove by rule 2. Yes, you replaced by epsilon. Okay. I got this particular concept. Okay. I just took one example. I framed some rules. Okay. Through this, I am going to define what is your rule, what is your grammar to construct context-free language. This is the production rule, P. Many terms I am going to bring, carefully remember. P. Who is P? Production rule. The rules what you created to construct any word or of a language is called production rule. And who is this particular S? Capital letter. Sometimes you will get A, B, everything. Okay, A, B, upper cases. All are called non-terminal symbols. What do you mean by that? Variable. This V stands for variable because I can replace S by epsilon. I can replace S by ASB. This capital S, capital A can be replaced. Whenever I represent uppercase letter, it can be replaceable by some other term. So we call it as non-terminal symbols. Sir, can I replace the small a? No. Can I replace the small b? No. All small letter including epsilon, sometime plus minus, cannot be replaced. They are called terminal symbols. T. T stands for terminal symbols, small letter, lower cases, even plus minus also. We'll discuss later. V stands for variable, or you can also call it as non-terminal symbols. Now P is a production rule, V is a variable, T is a terminal. Who is this S? Always starts from start symbol S. So S is the igniter, start symbol. Now through this, let us define what is your definition of the context-free grammar. Context-free grammar is a formal grammar which is used to generate all possible pattern, this pattern or any pattern of a string in a given finite language. Whatever the language I gave, from that I brought it. This context-free grammar as defined by 4 tuple. What is that 4 tuple? Yes, I hope you got it. This P, this V, this T, this S. The 4 tuples are grammar G equal to V. Yes, I have given. V stands for variable or non-terminal. T stands for terminal. P stands for production rule. S stands for start symbol. Now we will write it in the definition. The definition says where V equal to variable or non-terminal, and T is nothing but terminal, and P is nothing but production rule, and S is nothing but start symbol. Okay, so this is the basic definition of context-free grammar. Through this context-free grammar, I will do some problems in this particular video. Now let us have W power R. I hope you know this R represents reverse. Whatever the string you have, same string you keep it here, but reverse. Okay, that is called reverse. So I just made some examples. Just to take this example, stand in the middle. If you stand in the middle, A, B, B, reverse it, B, B, A. Stand in the middle. I will keep the red dot here. B, B, A, reverse. A, B, B. Okay, so this is nothing but your reversing. Though this is your W, this is your W power R. That is reverse. Now, let us take this particular example. B, B, A, B, B. Now, how I am going to create production rule? Now, you should think. This is what the challenge. Most of the time, you will stand in the middle. Okay, if you stand in the middle, both side A. Again, both side A. Sir, now I need something else, sir. Both side B. Sir, again, both side B. So, overall to implement what we need, if you stand in the middle, both side B, both side A. So, who is the standing point? Middle. So, that is replaced by S. So, one rule is both side A. Another rule is both side B. Sir, how to kill this S? Epsilon. Usually, we will bring this. So, I made the 3 rules. Now, I am going to start this particular work. Okay. Now, if I stand here, you may think, sir, start from both side A. No, I am sorry. If you start from both side A, again replace this S by both side A. Again replace means the first created A will go to the boundary. Okay. Now, carefully see how I am creating. First, you start from B, outermost area. So, that is the major aim. Now, it is something like there is a lake. You are dropping a stone in the middle of the lake. The first time when the ripple created, that first ripple becomes the boundary. Am I right? When I create one more stone, one more ripple. One more stone, one more ripple. When I drop the fourth stone, fourth ripple might have created. But the first ripple created might have went to boundary. The same logic applies here. So, we are ready with rule number 2. I hope this is the first ripple, that boundary. Replace S by one more time B. Okay, I need second round B. Okay, ready? Rule 2. Now, 2 B's came. Next, what do you need, sir? 2 A's. Okay, 1 A. Come on, replace by rule 1. Done. Replace by rule 1. Done. Yes. Now, I don't want this particular S. Kill the S by epsilon. That's all. Completed. Now, this is nothing but production rule P. In solving any problem, your rule is for the given language, you are not just supposed to create production rule. You should create the grammar VTPS. Now, what is the grammar VTPS? One by one, you should see. Who is V? Capital letters. Yes. Who is T? Small letters. A, B, epsilon. Who is production rule? This is your production rule. S becomes ASA. Also BSB. Also epsilon. This pipeline symbol says also and like that. Okay, instead of writing one more step, I am writing in the same step because S is common. Who is S? Start symbol, start state. Okay, so this is your problem for W power R. I have created the grammar VTPS. Let us solve another problem. A power n, B power n. In the example itself, I discussed A power n, B power n. What is the language? Ready, sir. Now, what is that particular example I took? 4A is 4B. Come on. Where I should stand in the middle. Okay. This side A, that side B. Production rule. You can tell me. This side A, this side B. Come on. I hope. Yes, your right answer. A, S, B. Am I right? Yes, very good. Because one side A, one side B. Now you replace A by S by ASB, S by ASB. How to kill? Yes, epsilon. So we will start the work. ASB. One more time you create. One more time you create. One more time you create. I took example 4A 4B. Sir, I will take 6A 6B. Then you keep on substitute 6 times. Kill the S. Ready. Okay. Now what is your VTPS? V stands for variable s, t, a, b, epsilon, production rule I have made, start symbol I made. Let us see one more problem. A power n, b power 2n. That is, for 1a, there are 2 b's. Let us have the language. 1a, 2b, 2a, 4b, 3a, 6b. So double. Now, if you take this as an example, carefully listen. You cannot stand in the middle. Now, you stand here. This is the middle actually. One side A, one side B. One side A, one side B. I hope now your brain started thinking. Very good. One side A, one side 2B. Another A, another 2B, which means one side 1A, other side 2Bs. Now, I created the production rule. I hope you got it. One side A, other side 2B, because I always need 2N, you know. Like that it is. Now, keep on substitute A one side, 2B's other side. How to kill S? Epsilon. That's all. Now, you start the work. A, S, B, B. Now, I need 2A, 4B. Replace S by again rule 1. Done. I hope I got it. How to kill F's? Epsilon. Accepted. Now, this is your grammar. VTPS. Who is V? Capital letter S. Who is variable? Capital letter S. Who is a terminal? A, B, epsilon. Production rule is here. Start symbol is ready. With this, I would like to complete your context-free language and how to create context-free grammar for the same. In this coming videos, lectures, we will always learn this context-free grammar with parse tree and some rules based on LMD and RMD called derivations, and we will also discuss about ambiguity. Then finally we will go to push down automata. Thank you.